Introducing certificates. One of the problems we have in today's information age is proving that a message, whether it be an email message or a web page or a file or whatever, actually comes from the person that you believe it should have come from. So suppose Bob Jones has just sent us an email. How do we actually know that Bob really sent it? Well, to combat this problem, Windows 2003 supports the use of a public key infrastructure. A public key infrastructure, or PKI, is a collection of digital certificates, certification authorities, or CAs, and other registration authorities that verify and authenticate each party involved in an electronic transaction through the use of public key cryptography. So what can we do with a public key infrastructure? Well, PKI has many uses. For example, the encrypting file system lets you specify people that can decrypt your files in the event that you don't remember your password. These people, called recovery agents, use certificates to decrypt your information. IPsec is a method used to authenticate and encrypt IP communications between two or more systems across the internet. Windows 2003 has 3 solutions available when using IPsec. They can use a simple password, which is not the best as far as security goes. They can use Kerberos authentication, and this is much better than a password, but this option requires that both systems are members of the same forest. Or they can use the third option, which is using certificates. Certificates still allow the system to communicate even if they're not members of the same forest. Now you can also use certificates to secure web access. Using certificates to secure web access can be a good idea, especially if you have, say, an intranet that you want staff members to be able to access confidential information, but you might have contractors that work for you and you only want them to be able to see certain information, so you can use certificates for that. Now, if you use smart cards in your environment, then certificates are actually a requirement. Smart cards allow you to insert a small credit-sized card into a smart card reader, and this smart card contains a certificate to provide additional security when you log onto your network. Now, we can also use signatures to create a hash value from a software file and encrypt that file using our private key. Then users can decrypt the file using our public key and verify that the file has indeed come from us and is authentic and not some virus or something nasty. So a signature is not really for encrypting anything. This is left up to our public and private keys. The signature is only really useful for authenticating a file as being genuine. Now, this might all sound a little complex at this stage, and make no mistake, this is a rather complex subject, but hopefully we're going to help this all make sense to you in a short while. The first thing we need to talk about when dealing with PKI is the topic of keys. So what is a key? Well, a key is simply a mathematical formula which can be applied to a file to produce a hash value. The first type of key we'll look at is the public and private key pair. Public and private keys are more secure than symmetric keys, which we'll look at in a minute, but they work slower. We use a public key to encrypt data. The private key is used to decrypt whatever we encrypted with the public key. Now, the public key is exactly that. It's public. It doesn't matter if your public key is given to everyone, because without the private key to decrypt the information, having the public key is useless. Now, this also works in reverse as well. We can use the private key to encrypt a file or an email, and then the other people can use a public key to authenticate the file or email message to ensure that it actually came from us and has not been tampered with. Then we have a symmetric key. A symmetric key doesn't require a certificate authority, and an example of symmetric keys would be in using the encrypted file system, or EFS, in Windows 2003. Now, where EFS uses symmetric keys to encrypt the files on your hard drive, with symmetric keys we can use the same key to both encrypt and decrypt the data, and the benefit of using symmetric keys is that they're very, very fast.